Hello and welcome once again. In this video, we want to learn how to measure the GGT of a sample. So GGT is basically gamma glutamyl transferase. Okay, so this is an enzyme that is present in the liver and then the biliary tract, and is one of the most sensitive um, how do I say, one of the most sensitive indicators of hepatobiliary diseases. So when you have any disease of the liver and then the biliary tract, one of the enzymes that we're going to measure to help us is GGT. So, and then one important thing about GGT is that it has a very high negative predictive value, and so it's used to rule out any disease of the liver or the biliary tract. And mind you, it's used um, in association with other enzymes like ALT and then AST to do a differential diagnosis for any liver disease. So in this video, we're going to learn how to measure the GGT of a sample. And then I'm going to use a reagent that is very common here, the Medsource GGT reagent. So I have it here. This is how it looks like. So this is GGT by Medsource. So you store it in the fridge. That's 2 to 8 degrees Celsius. When you open it, you have a reagent 1 and then reagent 2. So that is how it looks like. This is reagent 1, and then this is reagent 2. Okay, so we're going to perform it. Okay, so also within the box, is the insert that tells you how it's done. So you prepare your working reagent. That's 1 part of reagent 2 to 4 parts of reagent 1. And after you prepare the working reagent, you take 1 ml of that and you add it to 100 microliters of your serum. Okay, this is a kinetic type of reaction. So this is how we are going to program it in the machine. I'm going to show you how it's done. I must say that the main difference between a kinetic and 2-point is that with the 2-point, we are measuring the change in absorbance at specific time at 2 points, but with a kinetic, we are measuring a change in rate. That is the difference. When you are doing a kinetic, you should be very accurate with your timing because you are measuring a change in rate. Okay, so basically that's about that. Let me show you how the programming is in the machine. So I select GGT. Where do I have that? Okay, that's GGT. I hope you can see it. So that's the name. That's the method will be kinetic. Then the wavelength 405 nanometers is here. Then your delay time or incubation time will be 60 seconds. Testing time will be 60 seconds. We are using 250 as the aspiration volume. Then the unit is international units per liter. Then these are reference range, these are linearity, and these are temperature. If you come to the calibration side for enzymes, they'll give you the calibration, the factor itself. So the factor is here, that's 1158. So you insert that at the factor side. You leave the calibration type to 1 point linear so that you can insert the K value. So basically that's how you program the machine. Okay, so let's go to how to perform the test. So you come to the test side and then you select the GGT. So it will tell you to aspirate your DI water. So I have it here and I'm going to aspirate it. Okay, so um, it's moving. You should always observe the graph, and the way it's moving, it's likely that there is a problem with some of the wavelengths. So I'm not going to accept this. I'm going to go back and then check my wavelengths again. So that will be at the maintenance side, and yes, one of the wavelength, the 504 wavelength, is out of range, and so we'll calibrate again. To calibrate, you take your DI water and then you click on the calibrate, and then here we go. So always be checking the graph. It's very, 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 very important. It shows you whether what you're doing is correct or not. Okay, so I've recalibrated, I save, and then I return. Come to the test side, go to GGT, and then aspirate my water. Okay, okay, so I'm going to prepare my working reagent. I'm going to take 1 ml of the reagent 1, and I'm going to add 250 microliters of reagent 2 to it to have my 1:4 ratio. Then after that, since I need 1 ml, I'm going to take 250 out of it. So I have, that's 1 ml into here, and then I'm going to change to 250. And then add to. So that's 250. I'm going to add and then mix, and then take another 250 out of what I just prepared to get, or to give me my 1 ml exactly that I need. So I mix, and then I'm going to discard 250 of it so that I get my 1. So I'm going to discard this. Okay, so I have my working reagent, that's 1 ml, and it's a ratio of 1:4. So I'm going to add 100 microliters of my sample to it, and then I'm going to time it for 1 minute exactly, and then I'll measure. Okay, so that's set to 100, and so 100 of the sample I'm going to add to this. Here we go, and then mix, and then click on my timer. You should be very accurate with the timing with the enzyme, because I told you with the kinetic types of reaction, it's measuring a change in rate, so you should be very accurate with your timing. Make sure it doesn't exceed. So exactly when we hear the alarm, we measure or we aspirate. Okay, so while we wait, let me show you the reference ranges that we have for adults and then children, then those within 6 months. Okay, so you should keep that in mind. Okay, so it's almost time, so I'm preparing, and then I aspirate. Then you should observe the graph for the direction of the reaction. I told you that the direction for this one is increasing reaction, so that is what we are expecting, that the graph continues to increase. Anything contrary to that, then we'll have to likely repeat our test again. So this is going to take about 2 minutes, and all has been programmed within the machine. Okay, so that's about that. If you have any questions, you can send them to me in the comment section, and I'll try and answer them. Okay. I hope you understood the procedure well, and this is almost the same for ALT and AST. And then with the ALP, the sample volume will be a little bit different. The sample volume is about 20 microliters, so almost the same procedure, just that you change the sample volume for ALP. So that's it. Our graph is looking fine. It means our result is going to be good. Okay. So this is a kinetic reaction where we are measuring a change in rate, or the rate of change. I think that's even better, the rate of change. With a 2-point kinetic, we are measuring the change in absorbance at 2 specific points. So this our result 35.65. So that is our result for the GGT. Okay, so I hope you learned something. Bye for now.